This tutorial is about the operating modes within DataSetup Wizard. We'll explain each of these to help you choose. Generally, you will find one that works for you for most all situations and you'll never change it again. And the defaults work for most people. The voltage mode refers to just how will the voltage be recorded and displayed as a default in the meter. You can choose phase to phase or phase to neutral. Whatever you choose, it's not going to have any effect on the power readings or anything like that. Everything will be the same. It's just how things are presented. For instance, if you're in phase to neutral mode and you log, you're going to see phase to neutral voltages always. Or if you're in phase to phase and you capture a waveform and you open the waveform, you'll see this being presented as phase to phase. In the case of waveforms, you can transform back and forth between phase to phase and phase to neutral. In the log, you only have one choice with the older models. It's whatever this is. It'll be phase to phase or phase to neutral. Frequency mode. Most people will find that 22 to 200 Hertz is fine for their situation. But you have other choices. There's fixed mode in DC for 50 Hertz, 60 Hertz, and 400 Hertz. With older meters, this can become important to save calculation time, but for all of our newer meters, this is only used for DC. When you're using a DC probe, of course, there's no frequency, and so any of these modes will work. This is just telling it how often to do its measurements within each second for purposes of averaging. You should get the same result, but it can have a difference too. Importantly, we also have another variable mode, 360 to 440 Hertz. This would be for avionics and military systems that run on 400 Hertz. Otherwise, this is the mode you probably want to be in. Our power mode, always positive. Unless you have a need to be in a different one, you want to keep it here. Our choices are negative allowed. This is for a regenerative load. If you're monitoring something that part of the time is generating power, part of the time is using power, like an oil well pump jack, this is the mode you want to be in. That way it'll show both positive and negative power, and it will net them so you can see what the net power usage is. Two current power is useful in certain situations where there are two CTs installed, like metering CTs, and you can't tell what the third phase current is. With two current power mode and 3 voltage inputs, you can determine the correct total power, as well as most other things. But unless you're in one of these two situations, always leave it in always positive. And the reason is, if you hook up a current probe backwards and you're in negative mode allowed, it will think that phase is generating power while the other ones are consuming it. And that phase will then cancel out another phase, which results in your total power being 1/3 of the correct amount. That's disastrous in a study. So if you go to always positive, the software in the meter will see that one phase is generating power when the others aren't, and it will say, oh, this current probe is backwards. It'll turn it around in software, and you'll get the correct results. The only issue left would be when you capture a waveform, you'll see that that particular current waveform is upside down because it's 180 degrees out of phase. Input ratios, typically we're going to be working with 1:1. But as you get into high power things or metering circuits, you're going to have situations where you need to apply input ratios to voltages and currents. Each of our current probes are self-identifying, and that means when you plug them in, the meter automatically knows what their ratio is, and so you don't need to add any additional ratio. But if you hook up to metering CTs, let's say, and they're set up for 100:1, then you're going to need to put 101 so that Parasite will be displaying and recording 100 times the value that's being presented to it, so you can see what the primary current is. For your convenience, we can do it individually or simply 100 to 1 for all currents. Now it's custom because of that. Also, with our medium voltage probes, our probes for measuring above 1,000 volts, they have input ratio. So if you use one of them, you may have to enter an input ratio for one of them, such as 100 to 1. And now they'll be reading correctly. So instead of saying 120 volts, it'll be saying 4160 or whatever. Next, we have the log start mode. How does the log start happening? Well, it can start now, which means as soon as I save this setup into the meter will start monitoring. Or you can start at a time, or you can set a date and time, and we hit OK. That's the time that when you load this into the meter, at that time it'll automatically start monitoring. It could be useful if you want to start at midnight or something. But typically, start manually is what everybody wants. This means that you're going to press a button to start monitoring, so you're going to be right there with it. You're going to see it at the time. You're going to have confidence that everything is just what you thought. Then stop time. We have choices of stop time. You can stop at a specific time. That could be handy if you're wanting to go for just a 24-hour or a 7-day week exactly. Or you can stop when full. It just keeps recording, and when it fills the internal memory, you're going to stop. This is handy if you're going to go for an extended period of time, but it's the first period of time you really care about. You just can't get back to get the data. You can stop now. That way, if you load this into the meter, it will just automatically stop monitoring. Generally, it's not used. And don't stop. This is the most popular. What this means is the meter is not going to stop unless you tell it to stop or turn it off. For most people, that's the mode they want.